we present a system for interactively abstracting 3D objects using Gestalt-based principles. The user sketches the wanted abstractions directly over the model. The underlying Gestalt-based optimization enables the system to select and to group 3D objects according to Gestalt rules, to abstract such Gestalt groups by a number of different operations that are suggested to the user, and to apply the abstraction to perceptually similar groups. The user marks elements and at the same time indicates the wanted abstraction by his strokes. After loading the model, the system analyzes the different groups and highlights them to the user. The user is able to join such groups and also to split them according to their needs. Now the model is ready for abstraction. Here we see how abstractions of a group can be transferred to similar groups using a brush tool. Here, this is done automatically. Groups of many small objects can be represented by an embracing object. The system is able to detect even rotated repetitions and replaces them by a few exemplars. Gestalt principles describe what we see as a form when multiple objects are shown. Visual groups are formed in dependency to the geometric configuration. Gestalt principles can also be applied in 3D space. Here, however, visibility plays an important role. Groupings that appear in one view might result in conflicting groupings for another view. Here, the regularity group is hidden by the proximity group for some view directions. In order to capture the full Gestalt-based 3D dependencies between shape elements, we introduce two novel terms, dominance and visibility. These terms are used to resolve conflicts between Gestalt groups and to control the amount of abstraction. Visibility is a local term that we compute using ambient occlusion. Here, the dark color indicates boxes with low visibility. If objects are seen only to a limited extent due to occlusion by other objects, they do not play an important role for visual abstraction. The dominance for a group is computed by analyzing the visibility of the group from different view directions. We do this by sampling the scene from different view positions and then determining the extent to which it is occluded by other elements. The easiest way to abstract a group of objects is to represent them by a single embracing object. To indicate the original elements, the system can also create a bas-relief from the original group that shows elements as some sort of engraving. Larger groups of objects will be represented by a few scaled exemplars. By using our sketched-based interface, even complex models can be processed efficiently. Only a few strokes are needed to create abstractions of the input model while maintaining structural characteristics. The system can also deal with complex groups. First, The stairs and also the base planes are abstracted by fewer exemplars. When sketching on the grid of columns, only the first row is abstracted due to its larger visibility. However, when the user also marks columns in the back, they can force the system to also abstract less visible groups. To abstract this city model, the user sketches a number of steps directly and thus is able to have artistic control over the result. In this example, we show that our method can also be applied to abstract a city model in a view-dependent way. The city model consists of regularly arranged buildings forming different Gestalt groups. Please note that most of these groups conflict with each other. While moving through the city, we evaluate the visibility of buildings based on the current viewpoint. The visibility is then used to resolve conflicts between Gestalt groups and to determine the amount of abstraction. On the right side, we can see the color-coded visibility and the resulting abstraction of the city shown from above. Even if some parts of the city are not visible from the current view, we use embracing objects for abstraction, which allows us to keep plausible shadows in the scene.